Alright, so this video here we're going to look at doing integrals using trigonometric substitution. So to do the trigonometric substitution for integrals involving the square root of a squared minus u squared, we'll let u equal a times sine theta. And for integrals involving square root of a squared plus u squared, we'll let u equal a tangent theta. And for integrals having square root of u squared minus a squared, we'll let u equal a secant theta. And the whole point of this, or what we're doing when we're doing trigonometric substitution, is to get rid of the radical, okay, out of the integrand. Alright, so let's take a look at an example. Alright, so we want to integrate dx over x squared times the square root of 9 minus x squared. Alright, so you can see here that we have the radical, we have 9 minus x squared. So that's in the form of a squared minus u squared. Okay, and remember that one told us to let u equal a sine theta. Okay, see, this is the one we have. Alright, so let's go back. Alright, so in this case you can see that a is equal to 3. Okay, see, this is the 9 is a squared. So we're going to let x equal a sine theta. Okay, so a is 3 times sine theta. So that gives us dx is equal to the derivative of this, so that's 3 cosine theta d theta. Alright, so let's go ahead and write our integral back. So we've got x squared square root of 9 minus x squared. Okay, so all we're going to do now is we're going to substitute all this in. Okay, we're going to take the 3 sine theta and plug that in for x here and here, and then you see we have dx is 3 cosine theta d theta, so we'll plug this in for dx. So that's going to give us 3 cosine theta d theta over, now in the place of x I'm going to put 3 sine theta, so that's 3 sine theta squared times the square root of 9 minus, and then in the place of x here I'm going to put 3 sine theta, and that's squared. Okay, alright, so this gives us 3 cosine theta d theta over, now let's square this, so 3 squared is 9, and then sine squared is just sine squared theta times the square root of 9 minus, and then I'll square this, so 3 squared is 9, and then square sine, so that's sine squared theta. Alright, and all we're doing right now, after we plugged everything in, all we're doing is just simplifying all this. Okay, so let's see what we can do. Alright, so that's going to be 3 cosine theta d theta over 9 sine squared theta. And then let's look under the radical. You see here how I can factor a 9 out? So that's going to be the square root of 9 times 1 minus sine squared theta. Okay, now I have the integral 3 cosine theta d theta over 9 sine squared theta. Alright, so now let's simplify this radical. Let's see, the square root of 9 is 3. Okay, so that's going to be times 3 times the square root of 1 minus sine squared. Well, what's 1 minus sine squared? That's just cosine squared theta. Okay, remember your identity, sine squared theta plus cosine squared theta equals 1. And if we move the sine squared over here, we get cosine squared as 1 minus sine squared. Okay. Alright, so let me change the pen color back. Alright, so we get 3. Well, we can go ahead and we can cancel this 3 and this 3. So that's going to leave us with cosine theta d theta over 9 sine squared theta times, see, square root of cosine squared theta is just cosine theta. Alright, now look what happens. See, the cosine thetas cancel, and I'm left with d theta over 9 sine squared theta. Okay, so this is going to give me, I'm going to separate the 9 from the fraction in here. So that's going to be 1/9, and I'll go ahead and take that 1/9 and bring it outside the integral. And that's going to leave me with 1 over sine squared theta d theta, which is 1/9, and then 1 over sine squared theta is cosecant squared theta d theta. And basically what we're doing by simplifying this, see, we've got the integral of cosecant squared theta. That's one of our integration formulas that we know. See, we know the integral of cosecant squared theta. So that's going to be 1/9, and the antiderivative of cosecant squared theta is negative cotangent theta plus c. And so that's going to give us negative 1/9 cotangent theta plus c. Okay, so now I need to get everything back in terms of x. Okay, get everything back in terms of x. Alright, so if you remember up here at the beginning, I let x equal 3 sine theta. Okay, so let's write that down. I've got x is equal to 3 sine theta. So that means sine theta is equal to x over 3. Alright, so let's look at our triangle. This is theta. Okay, and remember, sine is opposite over hypotenuse. So that's opposite over hypotenuse. Alright, so now I need to solve for the length of this side. Okay, well, what's the length of this side? Well, we'll just say this is y. Okay, so I know that x squared plus y squared equals 3 squared. Okay, so that's going to give me y squared is equal to 9 minus x squared. So y is equal to the square root of 9 minus x squared. So the length of this side here is 9 minus x squared, and it's the square root of that. Okay, alright, now remember, I have to substitute all this in to my final, well, to my answer here. Okay, so I have the integral of dx over x squared times the square root of 9 minus x squared. That's my original problem. Okay, that's what I started with. And that's going to equal negative 1/9 times cotangent theta. Well, what's cotangent theta? Well, remember that tangent theta is equal to opposite over adjacent, and so we know cotangent theta is adjacent over opposite. Alright, so times cotangent theta is adjacent over opposite. So that's going to be times the square root of 9 minus x squared, which is adjacent, over the opposite, x plus c. And this would be our final answer. Okay. Alright, so I hope this video helped. I'm gonna try to put some more examples. I'm gonna do one problem per video. I hope it helped, and check out my other videos, and you can subscribe if you like them. Alright, thanks.